Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of x plus 2 to the power of x equals to 35, and we will solve this problem for the integer values of x. So here you remember one thing is that we will find or solve this problem only for integer values of x. So that the very first thing we are going to do is here first we will take we will multiply the powers of both of the terms by 3, and we will write it as 3 to the power of x and its whole power 3 over 3, plus we have 2 to the power of x and we write it as 3 over 3, and it is equals to 35. And in the next step we will use here the nice exponential law, and according to this law we will write this term as 3 to the power of x over 3 and its whole cubed, plus we will write this term as 2 to the power of x over 3 and its whole cubed equals to 35. After this step here we need to change this nice exponential equation into the quadratic form, so that here we will just take a equals to 3 to the power of x over 3, and we take here b equals to 2 to the power of x over 3. And here you remember one thing is that we will write the conditions on a and b, and you see that our a and b belongs to the positive integers, and its other condition is a and b is not equals to 1. So if here you have these conditions on a and b, and now in the next step we will just put the values of a and b in this equation, and you will get here a cubed plus b cubed equals to 35. And now we will use here the nice cubic formula in order to expand this expression, and we write it as a plus b times of a squared minus ab and plus b squared, and this whole equals to 35. So here we need to make some you focus on the left hand side, and you have two factors multiplied by each other, and in the right hand side we have only one factor. And now if I can make the relation of a plus b and this term, then you will see that a plus b is less than a squared minus ab plus b squared. And now we find the factors of 35 which is satisfied this relation, which means that the one factor of 35 is less than the other factor. So here we have the only two factors which is satisfied this relation. So our one factor is 1 multiplied by 35, and it is equals to 35, because here you see that 1 is less than 35. And similarly the second factor is you have 5 times of 7 equals to 35, and our 5 is less than 7. So we have these two cases here, so we just move or apply these two cases, and we will find the values of x, or first we find the values of a and b. So now first I can write here case number 1. So in this case we will just compare both of the sides, and we will write it as, so here when you compare a plus b is less than this factor, we compare first these two factors, and here you will just write a plus b equals to 1, and our other factor is we write here a squared minus ab plus b square equals to 35. So here we have these two factors when we compare these two equations here. So now here I can take the square on a plus b. So when you take the square on this term, then you will get here a squared plus 2 times of ab plus b square equals to 1. And now we will just add this and this term. So here I can name this as equation number 1 and this as equation number 2. So now you will just add or subtract equation number 1 and 2. So now I can write here, we just subtract equation number 1 and equation number 2. So that when you subtract equation number 1 and equation number 2, then I can first write it here. Our equation number 1 is a squared minus ab plus b square equals to 35, and equation number 2 is a squared plus 2 times of ab plus b square equals to 1. So now we subtract these equations and you see that these are gone, and here you obtain minus 3 times of ab equals to 34, and here you get the value of ab equals to minus 34 over 3. So here you remember one thing is that over a and b is positive. I can write the condition here. So here you see that we have over a and b is positive integer, but here you will get a and b negative integer, so that we will just rejected this case here. So our this case is rejected, and we will proceed here the second case. So here I can write our second case, and you again see this term. So this is the our first case which is rejected, and this is the our second case. So now we can again compare these two, and you get here a plus b equals to 5 and a square minus ab plus b square equals to 7. So in the second case we have a plus b equals to 5 and a squared minus ab plus b square equals to 7. So now we have these two equations, and we will solve these two equations and find the values of a and b. So now here I can just find the value of a from this, and here you have a equals to 5 minus b, and we will put this value in this equation of static. So now we put the value of a here, then you will obtain, here you have b square, so the value a square, so the value of a is 5 minus b whole square, minus here you have a, and a equals to 5 minus b into b plus b square equals to 7. So now we will again simplify these terms, and we get the value of b here, so that you will open this formula and you get 25 plus b square minus 10 times of b, and now we multiply this b and minus on this term, and you get minus 5 times of b plus b square, and here you have b square equals to 7. So now we will add or subtract the like terms. So here you have b square plus b square, and b square equals to 3 times of b square, and you have minus 10 times of b, and minus 5b equals to minus 15 times of b, and after that we have a 25, and we move the 7 in the left hand side, and you will get here 25 minus 7, it is equals to plus 18, and this whole equals to 0. So in the next step we will divide each term by 3, because 3 be the common term. So we divide it on both of the sides. So here you see that these are gone, and 3 5s are 15 and 3 6s are 18. So this implies that b squared minus 5 times of b plus 6 equals to 0. So now we will make the factors of this nice equation, so that the factors of this equation are b squared minus 3 times of b minus 2 times of b plus 6 equals to 0. So this implies that here we take common b, and you get b minus 3, and here we take common minus 2, and you get b minus 3 equals to 0. So now we take common b minus 3 from both of the terms, and you get here b minus 2 equals to 0, so that here you obtain the value of b is 3, and similarly the value of b is 2. So now we put the values of b 3 and 2 here, and we get the value of a, so that here I can write a equals to 5 minus b, and now we put the value of b on a, and you get here when you put b equals to 3 here, then you get a equals to 3 5 minus 3 2, and similarly when you put b equals to 2 here, then you get a equals to 3. So that here we find the pairs of a and b are, so ab, our first pair which is get here is 2 3, and the pair of ab which we get in this case is equals to 3 and 2. So now we check which pair is satisfied the given condition, so that we will, if you put the values of a and b in the given equation, then you will not get here integers solution. So we will reject here because it is not gives the integers. If you put the value of ab here, then you cannot get the integers, and similarly here we put the values of a and b in this case, and you will easily get the integral value. So here you have a equals to 3 and b equals to 2, and in the start of the problem we will take here a equals to 3 to the power of x over 3 and b equals 2 to the power of x over 3. So now we back substitute the values of a and b. So we have a equals 3 to the power of x over 3 equals to 3, and the value of b is 2 to the power of x over 3 equals to 2. So when you compare both of the sides on both cases, then you get here x over 3 equals to 1, and this implies that x equals to 3. So this shows that x equals to 3 be the final answer of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.